We're getting closer to the end of this course. Now it's time to dive into some modern CSS features, learn more about resources where you can see what's coming up next, and also dive into some patterns, best practices, and useful tools that will be really helpful to you when you work on your next project. So let's start with upcoming CSS features and where you can find out more about this in the next lecture. As mentioned at the very beginning of the course, CSS is split up into modules. You got a module on media queries, you got a module on selectors, you got a module on animations, and so on. Now, at the end of this module in this course here, you'll find a link to this page, which gives you an overview over the different working groups that work on new CSS features, sorted by these modules basically. Now on this page you see which groups exist and also what the current state of the results of that group is. For example, if it's a recommendation, which means browsers should implement that, and they regularly do that, or if it's just a draft, which browsers may implement, but which they don't have to yet, or which is not necessarily recommended to them yet. So you can scroll through that list and find out which groups exist. You can always click into one of these groups, like CSS Transitions, and read more about their work, what it's all about, what they plan, which syntax they'd like to see, and so on. This can be really interesting, but this also is something you don't regularly do, unless you work for a browser vendor. This is a nice place to dive deeper if you really want to go super deep into a specific feature. But generally, this is just what the browsers have to implement in the end, and what MDN, the Mozilla Developer Network, which we referenced quite a bit in this course, typically summarizes and makes more digestible. Still, this is the original work, or these are the summaries, the protocols of the original work groups, and this can be a nice place to dive deeper in case you're interested. Speaking of modern features, here is one we'll actually use in our course project: CSS variables. Now, what does this mean? Consider this case. We got CSS code where we got different selectors, and let's say they share some common functionality, like a color which you reuse. This could also be some unit though. This could be something like one rem which you use again and again. CSS variables are a relatively new feature which allow you to put that reused value into a variable which you define with this strange looking syntax --my--color. Now this is a property which kind of exists. The browser understands that this now should become a custom variable, and then you can reuse that variable with that var function. Also note that the variable here is defined in that root pseudo selector, which in the end refers to the entire document or to every element. You could also place it on a specific element selector, but then this variable would only be usable within that selector. So with the snippet you see here, you define it once and you can use it everywhere in your document, everywhere on your page. And there also is a special syntax, which you see at the very bottom, where we provide a second value. This is a fallback value in case the variable is not defined yet. Be aware, this is not a fallback value for browsers which don't support variables, because they won't even understand the var function. This really is just a fallback for cases where you reference a variable and for some reason it isn't set yet, maybe because you forgot to import some other file where you define it. Then this fallback value will kick in, not in browsers which don't support variables. Speaking of browser support, if we check can I use for CSS variables, we see that browser support is generally pretty good, but Internet Explorer doesn't support it at all. So if you also need to support Internet Explorer, and chances are you do, at least version 11, then you can't use variables. You can't use CSS variables. If you don't need to do that, they are a real alternative though. And in the future, of course, when the usage of Internet Explorer becomes less and less, variables become more of an option. Now let's see them in action in our project. Back in our project, if we open the shared CSS file, we see a couple of values that we repeat all over again. Well, actually, I'm not going to replace everything with CSS variables. This is something you can definitely do though, but I want to focus on colors. Be aware that you could use them for units like RAM and so on too. But we can already see that we reuse colors. For example, in that shared CSS file, if we scroll through it from top to bottom, this red color, we're using it twice here already. And if we scroll down further, we see that we also reuse that green color. So here we can also see that. So it sounds like a good idea to put that green color and that red color into a CSS variable. Let's do that. All the way at the top, even above that universal selector, I'll add my root pseudo selector. Again, this selects the entire document. In that root selector, we can now add a variable with this special syntax you learned by adding 2 dashes. Now this is important. And then the name of your variable. For example, dark-green. Now that name is totally up to you. You then add a colon and then your value, like this dark green. Now this variable is defined and we can reuse it by that name. Now let's also put that red color into such a variable. So let's grab that hex code, scroll up to the root selector again, and then maybe highlight color and use that color. Now, of course, you might bring these names more into line. I'm using different names deliberately to really highlight and emphasize that you can use different names, that you can use custom names and name this however you want. And now with that, we have these variables defined. Now, of course, we want to use them. Now, to use them, let's start with the green one maybe, dark green, and let's search the occurrences of this dark green color. If we scroll down, here we see on the button, we use it as a background. We now use it with the special var function. Here we simply add the name, and we can add this as a fallback so that it uses this color in cases where somehow dark green is not set. Here this is not required because we do set it at the top, but this is how you could specify such a fallback. This is mostly interesting if you work with third-party packages that provide some variables where you might not be sure if it's defined or not. So here I'll repeat that, this time without the fallback, because as I said, we don't need it. So use the var function here and use it down here where we got a color too. Now the other function, the other color I should say we have is the highlight color. So let's grab that too and let's search the occurrences of that color in our code. Here we are. And there I'll again use the var function, enter the variable name, and we're done. And the same down here where we also use that color. With that, if we scroll through, that should be all occurrences of these colors. Now if we save that and we reload, we see no difference. And that is a good thing because that means that it works. We shouldn't see a difference here. We do style everything with variables successfully. We can see that if we inspect our call to action button here, for example, there you can see that for the background, we got our highlight color. And if we uncheck this, the background is gone. So this really seems to work. I can also see that there seems to be some leftover color. Here it is. So maybe here for that color in our shared file still, we should also use var. And then here it's dark-green. Now if we save that and we reload, then we can see that there we also got our dark green color. Now here it's actually overwritten for that start hosting button, but for the other elements here we can see it's having an effect. So this is how we can use CSS variables. Later in this course, when we dive into Sass, a preprocessor for CSS, we'll see an alternative to this. But here we already got a nice feature which we can use to save ourselves some time, because the clear advantage of the CSS variables is that we define them once, and if we ever decide to change this color, we only need to do it in one place. And the same, of course, if we were to define a font size or something like this here. We only need to change it once, and it will automatically be updated in the entire document. That's the great advantage. The disadvantage is the browser support, as I mentioned. Right now, Internet Explorer doesn't support it, so that might be a reason why you can't use them yet, but in the future, this will be really great. We had a look at CSS variables, and one problem there was browser support. Now let's stay in that world. Obviously, our users are able to use different browsers, and different browsers implement new features differently and at different speed. Once a certain feature reaches recommendation state, you saw that earlier in this module, it should be implemented in all browsers equally. But until then, each browser might not implement it, or implement some of its features, or maybe implement some features differently than other browsers do, simply to try how it works, how the users of that browser use that feature, and so on. For this, we got vendor prefixes. This is a mechanism which allows browser vendors to implement an upcoming feature in an early version without breaking the feature when it finally gets released. Here's an example. Flexbox. We added by setting display to flex, and nowadays the support for this is pretty good. A few years ago, when that standard was brand new and in very active development, browsers started to implement Flexbox step by implementing prefixed versions of the flex value. Here are some examples. Now, the interesting thing here is these are special values which only work in some browsers. For example, WebKit works in older versions of Safari, WebKit Flex in newer versions, MS Flexbox in Internet Explorer and Edge. So these values are not understood by other browsers, but they don't need to understand it because they either already implement the flex value or their own prefixed version. Why do we use these prefixes at all? Why don't they just all use flex? Because if the standard then changes or becomes finalized, and they therefore all implement the same specification, then if they suddenly override the flex value to now work different than it used to be, a lot of websites that were early adopters of that technology would get broken. Therefore, they have their early adopter implementation, the prefixed version, which they don't change even if the standard changes or becomes final, and then they implement their final version once that is the case. So now they got different implementations, and this allows you as a developer to use these features ahead of time. It also ensures that your web page won't suddenly break, and it also, that's another advantage, allows you to safely implement a certain feature which will still work, at least to some extent, even in older browsers. Because, let's say, an older version of Safari already supported Flexbox with WebKit Box, but didn't support it with display flex. Well, if you also provide that vendor prefix, it will understand this. It won't understand the other values for display, but it will then just ignore them. That's how the web works. And therefore, you can still use Flexbox even in that older version, even though it doesn't support flex yet. I hope this makes sense. So vendor prefixes are really great as they allow us to implement new features ahead of time and even support older browsers. Now let's see that in action on our website. How would we implement such prefixes? It's actually recommended to implement prefixes for Flexbox, so let's do that. Let's search for a flex value in our shared CSS file, like here. And the correct way of implementing this would be to specify the display property a couple of times, and the final standard, the default one, should be at the very bottom, because your code is parsed from top to bottom, so they will start with the older versions, and that's important so that the older versions don't override the newer ones. And if they understand the newer one, it will just override the older ones, which they also might have understood. Otherwise, if they don't understand the newer one, but an older one, they'll use that. If they don't understand any of these, well, it just won't work. So here we could add WebKit Box. We could then add display MS Flexbox. And we could add display WebKit Flex for newer versions of Safari. This is the correct setup. This one overrides the legacy versions. So if a browser understands the new one, it'll use that one. If it doesn't, maybe one of these can kick in. With that, if we save that and we go back and we reload our page, everything should still work there as it did before, because we didn't break anything. We now just have a chance of also making this work on older browsers. So we had a look at these vendor prefixes. The question that of course comes up is, which prefix should you use? Now there is a page, what CSS to prefix. this gives a nice indication. It also links to can I use, which you also should use to find out where prefixes are needed. So if we quickly check the Flexbox page on can I use, you can click show all to also see all browser versions. And there, for example, for older Chrome versions, you'll also see that there is partial support with the WebKit prefix. The same is true for other browsers too. So here you can see which prefixes might be needed to support these older versions. And that should I prefix page is of course a really great source to get a quick overview. There you see which features do not need prefixes and which ones should be prefixed. And then you even see the syntax you should use. So this is a really valuable resource which helps you write code that works in more browsers. However, clearly it is very cumbersome to check this for every feature you add and for manually adding all these prefixes. Thankfully, there is a tool for that, Auto Prefixer. You can simply Google for CSS Auto Prefixer and you should find this GitHub page here, Post CSS Auto Prefixer. This is a tool which automatically fetches a list of properties you should prefix and then adds these prefixes to your code. So it simply runs over your code and adds the prefixes. And you specify which browsers you want to support, and based on that list of browsers you want to support, it does the prefixing. So let's see this in action. If you scroll over that, you see multiple ways of including it. You can include it in your Gulp or Webpack workflow, for example. This is the way it's used most often, by the way. But if you don't have such a tool or workflow, and we don't have one, you can also just Google for CSS Auto Prefixer again, and you'll find Auto Prefixer online. Now, if you open this page, you can just paste your code into this page. So for example, we could grab our shared code and put it into that page. And it would then, on the right, give us the prefixed version of that code. So as you see, it automatically added a lot of prefixes, for example, for a grid, and so on. And now we could just grab that code on the right and put it back into our code, or maybe even better than that, into a separate version. So shared prod.css, for example. By doing this, you now have a prefixed version of your code, which you can now import into your file instead of the old code, and which now should work in more and also older browsers. We saw vendor prefixes. Sometimes you can't implement a vendor prefix for a certain feature though. Or maybe you can implement vendor prefixes, but some browsers, which your users might use, don't even support these prefixed versions. So some features simply aren't implemented in some browsers. Now the supports query can help with that. It looks a bit like a media query, but it's @supports. And the condition simply is a property value pair where you can simply check if that property and also that value, that's important, the value is not ignored, if that is supported by the browser. So in the end, the browser simply checks, can I read and use that? If the browser can't, then it will not execute the code between the curly braces. If it can, it will do so. This is of course especially useful if you got a bunch of code which depends on one feature. For example, you want to use the grid, and obviously the grid code itself depends on the grid being available, but maybe you got some other code too which assumes that everything is positioned in a grid. Maybe your font size is adjusted accordingly, or some elements get a width of 100% so that they look good in the grid. Well, all of that is something you don't want to apply if the browser doesn't support it. And therefore a support query can be really useful. Let's see how it works in our code. Back in our code, and here I'm in the regular shared.css file, not in the prefixed one. Though of course theoretically you would add it there too, or you should add it in the code you implement in the end. But in that normal shared CSS file, what could we check with our supports query? Well, obviously, we could check if we can really use a grid. Now, the good thing about our page is, even if a browser doesn't support the grid, it will still look good. Because, for example, our main layout is simply a one-column grid. So if the grid is not supported, elements are just positioned beneath each other. The biggest problem will just be that the header overlaps our main image. But that is still something we can avoid with such a query. So we add @supports, and then we check if display grid is supported. If the browser can't parse this, the code which is in there won't get executed. Now what's in there? We put our body code in there, like this. If we add body in here, then this code will only run if the grid is supported. Now obviously we don't care about the font family, this is not related to the grid, so let's remove it. The other code, however, is related to the grid being supported. The height of 100% is only needed if we do use the grid, because we rely on the height of 100% with our grid row of auto in the middle. The margin should also only be set to 0 if we use the grid. So what we do is we move our other body declaration here, that rule to be precise, we move it above our supports query so that this will run first. Then, if the browser supports the grid, this will execute and override parts of the body. And in the original body, we get rid of all the grid-related code. We don't need that. But we do comment in the padding top so that we got that distance or that the content isn't overlapped by the header. And we also keep the font family and margin 0 because that should apply all the time. Now in our supports query, margin 0 is not needed. We added in the general rule. But then the grid is only used if the browser supports it. Now with that, we're almost done. One thing we should override here. Here, we of course should set our padding top to 0 so that we override the padding top we introduce otherwise. Because if we can use the grid, we don't need that. We reserve space for the header with that extra row. So now we can save that and reload. And everything looks just as it did before. Because now the supports query kicks in. We can see that if we inspect the body, this is all applied. We see the grid here. So this does kick in. It does have an effect because our browser supports the grid. In browsers which do not support it, we still get a decent layout even without the grid due to our general styling here. So this is one example of how we could use the supports query. Please also be aware that you can use multiple conditions. You can use and or also not, so something like and not, to create more complex queries. So you could check if display grid is understood, but if not, something else is the case. This allows you to build more complex supports queries. Most of the time, you just need simple ones like this, so that you are able to use some next-gen feature if the browser supports it, but that you provide a decent fallback otherwise. And the typical setup is, of course, that you define the fallback first and override it with your better solution if the support query does allow access. We stay in the world of things not working in a browser. Let's talk about polyfills. What is a polyfill? A polyfill is a JavaScript package which enables certain CSS features in browsers which would not support it otherwise. Now, obviously, we learned about vendor prefixes, which help us support older browsers, and about the supports query, which helps us implementing nice fallbacks. Sometimes there is no prefix we can use because some browser simply doesn't support a feature, not even with a prefix. And we also don't want to implement a fallback. We want to use that cool feature which we can use in modern browsers too. For some CSS features, so-called polyfills exist. These are JavaScript packages which you can download and import into your code, and they will simply parse your CSS code and then style your page accordingly with some JavaScript logic. So they basically implement a certain feature by falling back to other CSS features and kind of replicating that look you wanted to have. Now, polyfills are not available for every CSS feature though. For example, for the grid, there are no polyfills because the grid uses some techniques that simply can't be replicated easily with vanilla CSS and JavaScript. But for some features, polyfills are an option. There's something important to keep in mind though. Polyfills come at a cost. It's a JavaScript package you download, you add, and you import into your HTML file. Therefore, your users have to download it, and then it will execute, it will parse the DOM, it will manipulate some styles. This all impacts the performance of your page. So especially for bigger polyfills, because some feature might be very complicated to replicate, you should really consider if implementing a fallback with supports or something like that isn't a better solution. If you come to the conclusion that it isn't, polyfills are a great tool, but you should really use them with care and use them rarely. Now, to give you an idea about what could be polyfill when it comes to CSS, for example, REMs. Older browsers don't support REM. There is a polyfill, and you find a link to this article, of course, at the end of this module. There is a polyfill which you can download and import, which will essentially just convert all your REM declarations to pixels, which are supported by older browsers too. And there are a couple of such polyfills, as you can see. There are also polyfills for background image related properties and so on. So if you need that feature and you need to support such old browsers, definitely consider using such polyfills. So as you probably guessed by now, developing for the web isn't trivial because we need to support many browsers. At least in some of our pages we need to do that. Another problem we face, besides some features not being supported in some browsers, are cross-browser inconsistencies. This means that different browsers use different defaults. You remember these default stylings some elements get? The default font size of H1 text, the default font family which gets used, things like that. Browsers implement that differently. For some elements we might have different margins or paddings, different box sizing behavior. That box sizing is set to border box in some browsers for some elements by default, for example, and so on. This is not necessarily bad. Different browsers offer different defaults, and some users might pick a browser because of some of the defaults it offers. But some defaults are also annoying, and you want to have a consistent look of your web page across browsers too. Therefore, you can implement some reset libraries like normalize CSS, which is a CSS package you add as one of the first imports or as the first import in your HTML file, which basically overrides some of the global browser defaults. So for example, this could set box sizing to border box for all elements. Or you do that manually, of course. For example, in our code, in the shared CSS file, we are doing such a reset with that universal selector where we set box sizing to border box. This is one of the things normalized CSS or other packages like it might do for you. You can, of course, do it on your own. Now, very important to keep in mind, if you use a package like normalized CSS, which resets a bunch of things, that of course is additional code your users need to download, and therefore this increases the size of your page, so to say. Still, it might be worth it, but there are a lot of arguments these days that it maybe is just better to do that box sizing reset, because that really is annoying if it doesn't work like this, and not reset anything else, but simply override things like font sizes, like font families or colors, if you work with that specific element which actually is affected. Because you could also argue that packages like normalized CSS reset a lot of styles which might never be used in your page because you never use that element which it resets. For example, if you never use a select element, it doesn't matter to you if the styles for it are reset globally or not. So, keeping in mind that resetting some features makes sense and that you can do it manually with the star selector or by using packages is definitely something which is important. Enough of cross-browser problems, unsupported features. Let's think about our code. How should we actually name our class names? As you saw in this course, the class selector is probably the selector you use the most often, because it allows you to create reusable styles, and even if you only apply a class to one element, you can give it a really expressive name, which makes it far easier to understand your CSS code. Here are some do's and don'ts when it comes to class names. Do's. Use kebab case. So this is this class name style where you use lowercase characters and separate words with dashes. It's important because CSS is case insensitive. So if you use snake case, for example, where you have one word and separate the words with uppercase characters, this is not something CSS understands. For CSS, snake case with a capital C is the same as snake case with a lowercase c. So if you got two classes with the same name and you think they are different, they aren't. And this can lead to strange behaviors. Additionally, since you can't use this snake case version, you would have to use really long words, without any separators, which are hard to read. So use 𝗓𝗢𝗢𝗘. It's easy to read, it's easy to understand, and the browser understands it too. Another important hint: name your classes by feature. For example, page title. It's very clear what this style will do. We don't know which element your page title is, if it's a H1, H2, or a div, but this doesn't matter. We know that this probably will refer to the page title. Don't name your classes by the style they're going to apply. For example, title blue is a really bad name. Yes, we can guess that this probably will color the title with a blue color, but we can see that by the properties and values you then use in that rule anyways. And if you ever change the color of your text to be red, then you probably have to rename your class. So this is a really bad class name. Name them by feature instead. In this course, I actually tried to follow a convention which is called block element modifier styles, BEM. This is a convention which makes sure that we name our classes in a uniform and consistent way across our project, and that we also prevent clashes. Because as you can imagine, the bigger your project gets, the higher the chance of you reusing some class name unintendedly. And all of a sudden, you might overwrite a style somewhere else in your page without you noticing it at first. Therefore, BEM enforces a certain way of naming your classes, which should minimize this risk. You obviously start with a dot in the selector, but then you have the block portion of the name, 2 underscores, the element portion, maybe 2 dashes, and then an optional modifier. Here's an example. Here we got a selector which selects the menu main item, which is big, or which has a big size. The block here is our main menu, hence menu main. You could of course also name this main menu. We select a single item in that main menu, and we select the item which is very big, which should receive some special style because it's big. The last part, the modifier, kind of goes against this rule of not naming classes by style, but in the end this is not the entire class name. The whole thing here is the entire class name. Here's another example. We got a selector which selects a button which has no special element, so all buttons, but which also has the success modifier. Now, mastering this is something which is very hard, obviously, and you can probably flame me for some of the class names used here. But if you follow this pattern in general, you already gain a lot. If we have a look at our source code here, you see I try to follow this. We got a main header here, we got the toggle button, and then we got a sub element in the toggle button. So these horizontal bars in the hamburger button. We got the brand in the main header, and so on. So this is the idea. Here we got a call to action modifier on the main nav item. These classes look a bit ugly, but they really help you prevent clashes of class names. And once you get into the idea of these class names, they also help you understand what a certain class selector is probably referring to. Now that we understand how we should write our code to work in as many browsers as possible and to be understandable and easy to maintain, there's another question that could come up. Once you dive deeper into CSS world, you'll find out that so-called CSS frameworks exist, things like Bootstrap. Now, what are they and when should you use them? Let's do a quick comparison. We have vanilla CSS, of course. With that, I mean CSS code we write with the base features. We write all our styles and layouts on our own if we don't use an extra package. With extra packages, I mean things like component frameworks, for example, Foundation or Bootstrap 4. These are simply third-party CSS packages. Often they also come with a JavaScript portion for some interactive elements, but in general, they are packages of CSS code which give you pre-styled components and utility classes. So in the end, they expose a bunch of CSS classes which you can start using. And if you apply one of their classes to one element, it immediately looks in a certain way because they did the styling. There also are utility frameworks like Tailwind CSS, which are also giving you some help. They offer you some styles on which you can build up on. They give you some utility classes, but they don't give you pre-styled components. They don't do all the work for you. Now let's take a look. Obviously, our project is written with vanilla CSS, all from scratch, all by ourselves. Now I'm on getbootstrap.com, which is the site of the Bootstrap package. The Bootstrap package is a CSS framework, which you can simply install by putting that link here into your HTML file. This will download the Bootstrap styles, and then you can start using their layout utilities, like their own grid, which is not based on CSS grid, but which actually uses Flexbox behind the scenes and allows you to use these helper classes you see here to build a grid. Or you use one of the many components they offer you, like these beautifully styled alerts, or like buttons, or things like their pre-styled form elements. These are all normal HTML elements, but by attaching the classes they offer to you, they immediately look the way they look here. Obviously, this has some great advantages. You save a lot of time writing these styles on your own, but I'll come back to a detailed comparison in a second. Let's also have a look at Tailwind CSS first. This is kind of an alternative to Bootstrap, but it follows a different approach. This does not offer with a bunch of components. You find no single component here. Instead, it offers a bunch of utility features. It also offers some layouting system, which makes it easy for you to position elements, and it does so by also exposing utility CSS classes, which you can add to your code, and these classes allow you to quickly achieve certain looks and styles and behaviors. Here, you got more control over the final outcome and the look of that outcome, but you still can build up on some of the utility classes without writing everything from scratch on your own. So which one should you use then? Well, let's have a look at some advantages and disadvantages. Vanilla CSS, of course, has the advantage that you have full control. You saw that in this course. We wrote everything from scratch on our own, therefore everything works and looks exactly the way we want it to be. You also have no, or at least very little, unnecessary code, at least if you write clean code and remove code you don't need anymore. You only have selectors and classes and rules which you need. You don't have any code lying around which doesn't do anything on your page. You are also free to name classes as you like, and whilst you should follow some best practices when it comes to this, this of course has the advantage that you, and hopefully your entire team, has an easier time understanding which class does what. Of course, there are disadvantages too. You have to build everything from scratch. This is a lot of work, and it also means that you have the full responsibility of your code. If you write bad code that doesn't run on some browser you need to support, that screws something up, that simply is too complex, well, then this is your fault and you'll have to fix it on your own. You might not even recognize it for quite some time. Still, overall, if you need full control and want to write highly optimized code, you of course have to put in the effort to do so, but then vanilla CSS gives you everything you need for that. Component frameworks like Bootstrap allow for very rapid development. You can build web pages in no time because all the components are already there. You just start dropping some classes on your HTML code. They also typically already follow some best practices, so the code which gets used behind the scenes should support many browsers and should also run relatively fast. And of course, a big advantage is you don't have to be a CSS expert to use these frameworks. You can theoretically just dive into their documentation and start using their classes. Having some CSS knowledge certainly helps, but you can build nice web pages without being an expert at all. The downside obviously is you get no or very little control. You can't really adjust the code. Well, in some frameworks you can do that by using Sass and so on, but it's harder and some things just might not be really changeable. Keep in mind you can always override rules set up by them by simply abusing cascading and specificity, but therefore you need to know what their rules are named like, and you might break other things while doing so. So this is possible, but should be used with care. Another disadvantage of component frameworks is that you might import unnecessary overhead code. If the framework gives you access to pre-styled buttons, forms, alerts, and modals, and you only use the forms, you still import the code for the other features without using it. That's unnecessary code your users have to download, so maybe also something you want to avoid. Now, that being said, Some modern frameworks like Bootstrap also allow you to only download parts of their feature sets. Still, it is something to be aware of. Finally, all websites tend to look the same. If you use Bootstrap with their default theme, your page is going to look just like that other page which uses Bootstrap with their default theme. Now, there are different themes, and there also are ways to adjust the theme, but in general, a common look can't be avoided. And once you are more experienced with web development, you can see that in the web. Some pages look deceivingly equal, even though they use different colors. Now, what about utility frameworks then? Utility frameworks allow for faster development. It's not as rapid as with component frameworks, because you still have to write the styles on your own. You have to write your components, so to say, on your own. But you can build up on some utility classes, so this definitely speeds up the development flow. They also should follow best practices, so you have to worry about that less. But on the other hand, since you build up on their code, you still have to write a lot of code on your own, and there you can mess things up again. But still, you need no expert knowledge. Now, that being said, you certainly need more knowledge than with component frameworks, because here you still build a lot on your own, but you don't start from scratch. So some knowledge is required, but you probably still don't need to be an expert. You certainly got more control than with component frameworks, but you still don't have full control, but a little bit at least. You still might have the problem of unnecessary overhead code here though. You still might import utility classes you just don't use, but at least you avoid the problem of all websites looking the same. There certainly are some elements which are reoccurring, but since you generally write your styles on components on your own, it's definitely less than you have with the component framework approach. Now with that, these were a lot of arguments. Which one should you choose? Well, you have to make that decision for yourself. Here are the pros and cons, and there is no wrong choice here. It really depends on what you're building, your time horizon, and what your goal is in the end. So let me summarize what we learned in this module. We had a look at CSS variables, a nice CSS feature which allows you to define your own reusable variables which store values like units, sizes, colors, in this example here 1 rem, in this module we saw it with hex codes, which you then can reuse in your CSS code. This of course is great because it allows you to define values once, which you can then use whenever you need them. And if you ever need to change that value, you change it in one place and it still affects the entire page. The disadvantage is that variables are only supported in modern browsers, but especially in the future, this is probably going to be a huge thing. We also had a detailed look at cross-browser support. We learned that browsers implement new features differently and with different speed. Until there is a clear recommendation, then they typically all have it implemented in the same way. And we can use vendor prefixes to already take advantage of some cutting-edge features and also to support older browsers, which might implement a certain feature with that vendor prefix at least. There also is the add supports query, which you can use to check if a certain feature is supported in a browser. And you enter a full property value declaration there, not just the property you want to use. This is very useful since it allows you to conditionally implement a certain feature and implement a fallback, which you override with the help of the support query. There also is the possibility of including polyfills. These are JavaScript packages which kind of emulate certain behaviors and make them available to browsers which don't support the native CSS feature. Now, polyfills are not available for all CSS features, and they're also not always the best choice. Sometimes implementing a fallback is better because polyfills come at a cost. The users have to download them, the JavaScript has to be executed. And of course, you're relying on the polyfill creator that there is no error in the polyfill. That's also something to consider. Another thing you should consider is normalizing CSS defaults across browsers. Now, this is really up to you, and there are packages like normalize.css. You learned about one important normalization that you typically want to implement, and that is resetting the box sizing to border box. But we can do that on our own. In general, you should be aware that browsers may have different defaults though, and therefore normalizing them and starting from the same, well, starting point might be something to consider. We also had a look at CSS class names. You should name them with kebab case, because CSS is case insensitive, and you should name them by feature and not by style. So a class like title-blue, that's bad, page title probably is better. In bigger projects, you also might face the issue of name collisions, so that you use the same class name accidentally twice and you hence override yourself. And concepts or approaches like BEM, block elephant modifier class names, can be a solution for that. You'll learn what this is, and we actually use that approach throughout the entire course. And last but not least, there is the choice of writing vanilla CSS code versus picking a framework like Bootstrap. If you write all the styles from scratch, you got full control, but you also got the entire work and responsibility. If you use a component framework like Bootstrap, you can build web pages much faster, but you might include code which you don't really need, hence you bloat the size of your web page, and of course, you also have less control over the code. Utility frameworks like Tailwind CSS can be a nice compromise, since they give you some utilities you can use, but don't do much else. So there you still write your styles on your own, you just got some, well, utility features to help you. And that's it for this module.